Hello everyone, welcome back to our channel gsipucmysuru. This is the fifth session of the sixth chapter, that is oscillators. In the last few sessions we discussed about the basics of oscillators, that is what is an oscillator, what exactly is a tank circuit, or how do we use this tank circuit in order to generate the oscillating signals or the sustained signals anta nodidvi. Apart from that, we also derived an expression for the voltage gain of a positive feedback oscillator, and what exactly is the meaning of LC oscillators, and the two different types of LC oscillators, that is Hartley oscillator and Colpitts oscillators. We also solved some of the problems on these LC oscillators. In today's session, we will be dealing with the next type of oscillator circuit, what is called as RC oscillators. LC oscillators, which we dealt in the earlier sessions, in that we were using two components, one is the L, the other one is C, that is L stands for inductance, the other one C stands for capacitance. But in these RC oscillators, R stands for resistors and C stands for capacitors. So we are going to make use of these two components, that is the resistors and the capacitors, in order to generate the oscillations. So RC oscillators are again classified into two types. One is the phase shift oscillators, the other one is the Wien bridge oscillators. Phase shift and the second one is Wien bridge oscillators. So in today's session we will be dealing with the phase shift oscillators. In the next sessions we will be dealing with Wien bridge oscillators. So R and C are the major two components which helps in generating the oscillating signals, and the feedback to the amplifier will be given with from these RC network. So what exactly is this phase shift oscillators, and how this R and C is playing a major role in generating the oscillations ಅನ್ನೋದನ್ನ ಇವಾಗ ನೋಡೋಣ. These RC oscillators are used to produce the low frequency signals. As I have already discussed about, in LC oscillators, that is the LC oscillators are majorly used to produce high frequency signals. But in the low frequency, in order to generate the low frequency signals with the help of LC oscillators, the circuit becomes bulkier and it will become expensive. So that disadvantage is completely eliminated with the help of this RC oscillators, where we are going to use the resistor and the capacitor in the combination in order to generate the low frequency signals. So let us try to understand the principle of phase shift in RC oscillators. So here we are going to use a capacitor and a resistor which will help us in order to generate the sustained oscillations. So this is R and this is a capacitor. Here we will be applying V in, and across this resistor we will be taking the output, that is V in is applied to the combination of this R and C, whereas the output is taken from the resistor. If an AC input voltage is applied across this combination, then the voltage across the resistor will always lead that signal, that is the applied voltage, at an angle of phi. That is, in the first year PUC itself we have studied regarding this in the application of AC and DC to passive components. So passive components ge ನಾವು AC ನ apply ಮಾಡಿದಾಗ the voltage between the resistor and the capacitor will be like this. The voltage across the resistor will always be leading the voltage across the capacitor. So whenever we are going to apply an AC voltage across the input, then the voltage across the resistor will always lead the applied signal at an angle of 90 degree. That is, the voltage across the resistor, that itself is nothing but V0. So V0 will always be leading the applied voltage ಅಂತ ಹೇಳಿದ್ರೆ V in at an angle of phi. So that phi, tan phi, can be written as XC divided by R. But XC ಅಂತ ಹೇಳಿದಾಗ that XC is equal to 1 divided by omega C whole divided by R. So this tan phi will be equal to 1 divided by omega C R. And this angle phi will entirely depend upon the value of the resistor as well as the capacitor. R and C ಹೇಗೆ ನಾವು select ಮಾಡ್ಕೊಳ್ತೀವಿ, according ಆಗಿ the angle phi will completely depend. If R value is equal to 0, if R value is equal to 0, then V0 will always lead V in at an angle of 90 degree, that is phi will be equal to 90 degree. If R is equal to infinity, then phi will be equal to 0 degree. So this phi will entirely depend upon the value of resistance what we are selecting. But it is in practice that we are going to select R in such a way that V0 will always lead the Vin, that is the output voltage will always lead the input voltage. So by proper selection of this R, we are going to generate the sinusoidal signals, or we are going to generate the sustained oscillations. So this is one RC network, but practically we are going to use 3 sets of RC network, where we will be having 3 resistors and 3 capacitors. 3 resistors and 3 capacitors anta ಹೇಳಿದಾಗ the circuit will be like this. Across this last resistor we will be taking the output. So these are C and these are R. Each network, each set of this RC will be producing a phase shift of 60 degree. So this R and C network will produce a phase shift of 60 degree, and this R and C will produce a phase shift of 60 degree, and another 60 degree will be produced by this last set. So totally there will be a phase shift of 60 plus 60 plus 60, that is 180 degree phase shift will be provided by this RC network. We are not going to use a single RC network, because when we are using only a single RC network, then only 60 degree phase shift will be provided. But in order to generate the sustained oscillations according to the Bar-Cousins criteria, there must be a total phase shift of 360 degree or 0 degree in the oscillating circuit. So in order to generate 180 degree from this feedback network or from this RC network, we are going to use 3 sets of RC network. Now let us try to understand the RC phase shift oscillator, or simply it is called as a phase shift oscillator. So in order to generate this phase shift oscillator, we are going to use op-amp as an amplifier. In the LC network, that is in the LC oscillator circuit, we use transistor in order to amplify the signal, or we use transistor in the amplifier circuit. But here in the RC oscillator, we are going to use op-amp in the amplifier circuit. Now let us try to draw the circuit what we are going to use in order to generate a sustained oscillation in this phase shift oscillator. As I have already told you that in the amplifier part, we are going to use op-amp in the inverting mode. So this is plus VCC, this is minus VCC. Here we will be having an input resistor which is named as Ri. The non-inverting input terminal will be grounded, and I will be having 3 sets of RC network. And here we will be having a feedback resistor. Here we will be extracting the output signal which is named as V0, and this is the output signal what we are getting. So these are the capacitors, these are the resistor. So I am having 3 sets of RC network. This is one set, this is another set, and this is the third set. So here I am using op-amp IC741 in the amplifier part. So this is the feedback part what we are using, and this is the amplifier part what we are using. The feedback circuit will take a portion of the output and provide that as the input for this op-amp. Since that is applied to the inverting input terminal of the op-amp, 180 degree phase shift will be provided by this amplifier circuit, whereas another 180 degree phase shift will be provided by this feedback circuit. So totally there will be a phase shift of 180 degree plus 180 degree, which is equal to 360 degree, which is one of the most important criteria in order to generate the electrical oscillations. So 180 degree and this RC network will provide a phase shift of 60 degree, this RC network will provide a phase shift of another 60, and this will provide another phase shift of 60 degree. So totally from the feedback circuit we will be getting a phase shift of 180 degree, and the other 180 degree phase shift will be getting from the inverting operational amplifier. And the frequency for this RC phase shift can be calculated using this 1 by 2 pi root 6 R into C, where R values will be same, R1, R2, R3. If I am going to call this as R1, R2 and R3, all these values will be same and the capacitance value will also be same. So, F is equal to 1 divided by 2 pi root 6 RC, and the amplifier gain, or the gain of the amplifier will be denoted by A, which will be equal to 29. The calculation of this part is not present in your syllabus. So, the gain of the amplifier A will be equal to 29. We know that A into beta must be equal to 1. So, beta is equal to 1 divided by 29. The gain A is equal to 29, whereas the beta, the feedback gain, will be equal to 1 divided by 29 in this phase shift oscillators. So, in the phase shift oscillators, we are going to use 3 sets of RC networks where this feedback circuit will provide a phase shift of 180 degree and the other 180 degree phase shift will be provided by the inverting op amp. So, totally there will be a phase shift of 360 degree. This feedback circuit is used to provide a portion of the output back to the inverting input terminal of the op amp. So, the phase shift oscillator, it provides a phase shift of 180 degree plus 180 degree, which is equal to 360 degree. So, RC phase shift andrunu onde athwa bari phase shift oscillator, it's one and the same. So, let us try to solve some problems on this phase shift oscillator. The very first problem from this phase shift oscillator is, a RC phase shift oscillator uses 3 identical RC sections in the feedback network. 3 identical RC sections antandre 3 sets of RC sections or 3 sets of RC network where all the values of R and C are same. The values of the components are R is equal to 680 ohms, R is equal to 680 ohms and C is equal to 220 nanofarad, that is 220 nanofarad. Determine the frequency of oscillation. Determine the frequency of oscillation. Here they have already mentioned that a RC phase shift oscillator. So, you can directly write the formula without getting any kind of confusions. So, frequency is equal to 1 divided by 2 pi root 6 R into C. So, 1 divided by 2 pi, direct values will be given in these kinds of problems. 1 divided by 2 pi root 6, R value is equal to 680 and C value is equal to 220 into nano ant helidre, its value is equal to 10 to the power of minus 9. So, let us simplify this. 1 divided by, when I am going to multiply 2 pi root 6 into 680 into 220, I will be getting 2301266.219 into 10 to the power of minus 9. So, let me divide this. So, I will be getting 0 point followed by 6 zeros, 1, 2, 3, 4, 5, 6, 4, 3, 4 into 10 to the power of minus 9. So, this is the frequency. Frequency will not be in terms of 10 to the power of negative values. The frequency will always be in terms of kilo, that is 10 to the power of 3, mega 10 to the power of 6, giga 10 to the power of 9. So, let us convert this by shifting this point towards the right side. 1, 2, 3, 4, 5, 6, 7, 8, 9, or let me convert it into 6 places only. 1, 2, 3, 4, 5, 6 places convert madidre F will be equal to 0.434 into 10 to the power of, sorry, this is 10 to the power of plus 9 because 10 to the power of minus 9 is in the denominator. When it goes to the numerator, it will become 10 to the power of plus 9. So, I have shift the point to 6 places. So, 10 to the power of 6 minus 6 into 10 to the power of 9. So, I will be getting F value as, this 10 power minus 6 gets cancelled with 10 to the power of 9 remaining 3. So, I will be getting 0.434 kilohertz. So, this is the final answer for this problem, 0.434 kilohertz or 0.434 into 10 to the power of 3. So problems are very simple in this RC oscillators also. Try to understand the problem, read the problem carefully and analyze which parameter is given, whether R is given, C is given or frequency. Accordingly use this formula f is equal to 1 divided by 2 pi root 6 RC and solve the problem. Now we will move on to the next problem. The second problem is, what should be the value of capacitor required for a phase shift oscillator? What should be the value of capacitor ಅಂತ ಹೇಳಿದ್ರೆ you have to find out the value of C to produce a frequency of 338 Hertz. Hertz is the unit of frequency. So frequency is given whose value is 338 Hertz. If the resistance used is 220 ohms. If the resistance ಅಂತ ಹೇಳಿದ್ರೆ R whose value is equal to 220 ohms. Now we are having a direct formula. F is equal to 1 divided by 2 pi root 6 into RC. F is given 338 is equal to 1 divided by 2 pi root 6. R value is 220 into C. C is unknown over here. So let's just cross multiply this. C na ikkade tagolna. C is equal to 1 divided by 2 pi root 6 into 220 into this term, that is 338. So let's multiply this denominator part. So I will be getting 1 divided by 1143864.67 1143864.67. So C is equal to 1 divided by that, the answer gives me 0 followed by 6 zeros 8742 farad. So C will always be in microfarad or picofarad. So let us shift this point to 6 spaces and check what will be the answer. 1, 2, 3, 4, 5, 6. So 0.874 into 10 to the power of minus 6 farad, or C is equal to 0.874 microfarad. So this is the final answer where the resistance and the frequency was given. You have to find out the capacitance. So capacitance value is 0.874 into 10 to the power of minus 6 farad or 0.874 microfarad. So make sure you are going to keep these capacitance values or the resistance value or the inductors or the frequency values in the standard form. Resistance will always be in the positive values, resistance and the frequency will always be in the 10 to the power of positive values. Capacitance and inductances will be always in the 10 to the power of negative values. 10 to the power of negative values anta andaga keep it in the standard forms, that is 10 to the power of minus 3 or 10 to the power of minus 6 or 10 power minus 9 or 10 power minus 12, that is milli or micro or nano or pico. In resistors and frequency anta bandaga 10 to the power of positive values irutte. Make sure you are keeping those answers in the standard forms, that is 10 to the power of 3 irbodu, 10 to the power of 6 irbodu, 10 to the power of 3 in the sense kilo, 10 to the power of 6 in the sense mega. So these are some of the points what you have to keep in your mind while solving these kinds of problems. Now let us move on to the last problem of this session. The third problem is, the frequency of a phase shift oscillator is 125 Hertz. Hertz is the unit for frequency and I have already mentioned that it is the frequency whose value is equal to 125 Hertz. If the value of the capacitance of the capacitor used is 0.22 microfarad, 0.22 microfarad, that is capacitance 0.22 microfarad. Calculate the value of resistance used. You have to calculate the resistance used. So you are having this direct formula, F is equal to 1 divided by 2 pi root 6 into RC. Root is present only for 6, not for R and C. So substitute these values. F value is 125 equals 2 pi root 6, R you have to find out, and C is 0.22 into 10 to the power of minus 6. So let's cross multiply this, retaining R to the LHS. R is equal to 1 divided by 2 pi root 6 into 0.22 into 10 to the power of minus 6, that is C value, and frequency value is 125. So R will be equal to 1 divided by 423.026 into 10 to the power of minus 6. So 1 divided by this answer gives me R is equal to 0.0023639 into 10 to the power of plus 6. 10 to the power of minus 6 is in the denominator. When it goes to the numerator, it will become 10 to the power of plus 6. So, instead of keeping it in mega ohms, that is 10 to the power of 6 iradrinda, it is nothing but mega. But mega anta helidaga this is a least value. So, let us try to shift this point. Mega 10 to the power of 6 illa anta helidre I have to keep it in 10 to the power of 3. So, let me shift this point to 3 places. 1, 2, 3. 2.36 into 10 to the power of minus 3 into 10 to the power of 6. 10 power minus 3 gets cancelled with 6 and retaining 10 to the power of plus 3. So, R is equal to 2.36 into 10 to the power of 3 ohms, or R is equal to 2.36 kilo ohms. Clear? So, this is the final answer of the resistance which has to be used in order to generate the frequency of 125 Hertz. The problems are simple. Here you are having only one formula, F is equal to 1 divided by 2 pi root 6 into RC. Please identify the parameter what is given correctly and use those values in the formula, that is 1 divided by 2 pi root 6 into RC. So, in this session we saw what exactly is the meaning of RC oscillator. RC oscillators anta helidaga we are going to use a network of R and C which provides a phase shift of 60 degree. So, in an oscillator circuit we require 180 degree phase shift from the feedback circuit. So, totally we will be using such 3 sets of network, such 3 sets of RC network which provides us a total phase shift of 60 plus 60 plus 60 which is equal to 180 degree. So, that 180 degree plus the 180 degree phase shift which is provided by the inverting op amp which is used in the amplifier circuit. So, totally there will be a phase shift of 360 degree which is one of the most important criteria in order to generate the sustained oscillations. We also solved some of the problems on this RC that is phase shift oscillator. In my next session I will be dealing with the next type of RC oscillator, that is Wien bridge oscillators. Thank you.